Okay, so in a previous chapter we talked about sequences, but we talked about the explicit formula for a sequence. And the idea with an explicit formula for a sequence is that it gives you any term in the sequence that you want to find. So if you want to find the 50th term in the sequence, you'd put 50 into that explicit formula, and it would give you the 50th term in the sequence. If you want to find the 100th term, put 100 into the equation, and you would get your answer for the 100th term in the sequence. Now, the thing that's not fun about it, using an explicit formula is if you're asked to find like the first 5 terms, because you have to put 1 in to find out what the first term is, and you have to put 2 in to find out what the second term is, and you have to put 3 in to find out what the third term is, and so on. So it takes more time to find the first 5 terms or the first 8 terms than what it would be to just find the 30th term in the sequence. So that's where the recursive formula comes in. The recursive formula is nice because where it's not so nice to try to find the 100th term or the 30th term in a sequence, it's really helpful to be able to find like the first 5 or 6 or 8 terms of the sequence. So in this first box it shows us, it talks about what a recursive formula is all about, and if you look down below, I'm going to change these notes up a little bit, so we're not going to use this first example. But if you look down below here in purple, basically it's a description of what's going on up here in the table. So if you look at the table, it says that the first part of the recursive formula, the top row, indicates the first term or the first few terms of the sequence. So that's what we're doing here. You can name a sequence any letter, just like we can name a function by any letter. So if we name it S, if we can name it L, we can name it A, B, it doesn't matter. So I'm just naming this particular sequence, sequence 1, or sequence S. And so S sub 1 would refer to the first term in the sequence. And we'd write down whatever the first term of the sequence is, what it would be equal to. So S sub 1 could equal 8. If that was the case, that means the first term of the sequence would be 8. Now remember, a sequence is a pattern of numbers. It follows a pattern. And so the second part tells you what the pattern is. So we would say to find the next term in the sequence, that's what we'll use S sub n to represent, whatever the term number we're trying to find. We take the previous term, so we have to know the previous one before it in order to find that term, plus whatever we're adding to each term in the sequence. So if we were adding 5 each time, it would be the previous term, S sub n minus 1, plus 5. So you always have this S sub n minus 1. This number here at the beginning, so this would end up being a number, and this would end up being a number. But otherwise, the rest of the sequence will always exist anytime we're asked to find the recursive formula. Now, we're also going to include this last phrase, the for integers n is greater than or equal to 2. What that phrase means is that we're going to use the formula, whatever S sub n minus 1 plus whatever we're adding each time, we're going to use that formula from the second term on, because we already know the first term, so we'd only need to use that formula for the second term on. Right now it's kind of abstract, so let's look at an example. Let's say, oops, I'll get rid of that. Let's say if we have the sequence 3, 7, 11, 15, and so on, and we're asked to write a recursive formula to represent the situation. Well, what you're going to do is you're going to start out with this fancy bracket. Now the way I like to remember it, we have an explicit formula and a recursive formula, both of which have weird names, both of which are words we don't really use that often, so it's hard to keep them straight. So a little tool to help you remember what the recursive formula represents is, if you think of cursive handwriting as really fancy handwriting, the recursive formula starts out with this fancy bracket here. So now the top row of this bracket is going to be, what's your first term? Let's say we call this, let's just call this sequence S again. So the first term in sequence S is 3. So to find the next term in the sequence, we're going to take the previous term, and if you notice what we're doing each time, to get to the next term, we're adding 4. So then we would take the previous term and add 4, and we would say for integers where n is greater than or equal to 2. Now sometimes people will change this up, and they'll accidentally write down, they'll just say, well, the previous term is 3, so I don't want to write S sub n minus 1. I'm just going to put a 3 here. Well, the problem with that is that only gives you the second term in the sequence. We want to be able to use this formula to come up with the sequence without having to see anything at all. So in other words, if I didn't know those terms in the sequence and I wanted to come up with a sequence now, because you'll be asked to do this in your assignment, what we would do is we know the first term is 3. So to find the next term in the sequence, we would take the previous term and add 4. Well, now the previous term is 3, so 3 plus 4 is 7. But now the previous term is not 3, it's now going to be 7. So now to find the next term in the sequence, we could take 7 plus 4, which is 11. And then 11 plus 4 is 15, and so on. So we came up with the first 4 terms of the sequence there. That's how we use the recursive formula. Let's look at a story problem. It says, consider the sequence A equals 10,000, 9,600, 9,200, and so on of dollar amounts left on a car loan if $400 is repaid each month. So we want to write a recursive formula here. So again, we're going to see that word cursive, so that reminds me, I need to start out with the fancy bracket. So now what I do is I start out with my first term. This is sequence A, so the first term in sequence A is 10,000. To find the next term in the sequence, we take the previous term, and if you notice, we're going down this time, and 10,000 minus 400 gives me 9,600. 9,600 minus 400 give me 9,200, and so on. It's also given to us here that we're paying $400 a month, so it's going to be minus 400. Now here's another note about this. If you want to do this on your calculators are already set up to you to do things recursively. Here's what I mean by that. Let's say we didn't know the sequence and we were just given the recursive formula. What you would do is, if you get out your calculator, we'll go to a calculator screen. What you do is you start out by just typing in, and this works for any scientific calculator or the CAS calculator. So any calculator will do this, even I think your cell phone calculators. But if you just type in 10,000 and hit enter, don't do anything else. What we've just done is we put this into our calculator's memory. So the calculator knows now that the first number we're going to use is 10,000. Now we type in what we're going to do to find the next term in the sequence. Well, we're subtracting 400 each time. So I'm going to type in minus 400. And you notice as soon as I hit the minus, this A and S came up. That refers to the previous answer. So we're going to take the previous answer minus 400, hit enter. Well, I don't want to always be hitting in, I don't want to type in 9,600 minus 400. I don't have to. Since we already told the calculator our first term was 10,000 and we're going to subtract 400 from each time, all I have to do is hit enter. If you notice, the nice thing about the CAS is every time you hit enter, it tells us what it did to get that answer, so we can see what we're doing. We're taking the previous term, the 8,800, minus 400. So if I was asked to find the first 5 terms of the sequence, I came up with them. Again, the way that you do that is you start out by typing in your initial amount, your first term in your sequence, your 10,000. Then just type in what you're going to do each time, so minus 400. Hit enter, and then every time you hit enter, it'll automatically figure out what the next term in the sequence will be. Okay, why don't you come up with the recursive formula now for this next term in the sequence. So pause the video and hit play when you're ready to check your answer. Okay, so you should have checked, or you should have already done this. So the first term in your sequence is going to be, this is sequence B now, and it will be 850. Oops. Now to find the next term in the sequence, we're going to take the previous term, and what are we doing each time? Well, we're going from 850 to 775, then 775 down to 700. Well, we're subtracting 75 each time. So we would say that we would use this formula for our second term on, so for integers where n is greater than or equal to 2. Okay, let's apply this to a story problem now. It says, the NCAA women's basketball tournament originally consists of 64 teams, which are paired in single elimination contests. At the end of each round of play, the number of teams proceeding to the next round is half the previous number. The sequence 64, 32, 16, 8, 4, and 2 gives the number of teams in the tournament at the beginning of round n. So this refers to the beginning of the first round. This would be the second round, the third, the fourth, the fifth, and the sixth. And you're not going to have any more than 6 rounds because after the 6th round is played, you know who the winner of the tournament is. So there's not going to be a 7th round. So that's important when we go to do this part to describe what numbers we're going to use for n. I'm going to skip part A. I want to make sure that we know how to do the recursive formula here. That's the important part for this problem. Because basically part A is just describing in words what we're going to do in this formula. So the first term in the sequence, let's call this, you can name it anything you want. If you want to use R to represent each round, you can use W for the women's, B for basketball, T for tournament, it doesn't matter. So I'm going to use T to represent the first round, or to represent the tournament. So the first round in the tournament is going to be 64 teams. To find the next term in the sequence, to find out how many teams will be playing in the next round, you would take the previous round and divide by 2. There's a number of ways that we could represent that. We could say divide by 2 like this. That would be fine. We can say divide by 2 as a fraction like that. Which would be fine. Or dividing by 2 is the same as multiplying by 1/2. So you could say 1/2 of t of the previous term. Any of those would be sufficient. Now the key here, though, is for our integers. We already know our first term, so I'm going to use this formula for starting with the second term, going all the way to, we said that there's 6 terms, so going all the way to the 6th term. So it would be, the term numbers would go from the second term to the 6th term that we would use in this formula. Okay, why don't you guys try one more on your own? See if you can figure out what's going on here. You don't have to worry about the first part, the recursive definition. Again, that's just writing it out in words. We want to just start with the formula, so let's just work on that. Okay, so you should have had a chance to start this one. So we're going to call this sequence C. So the first term of the sequence is 324. To find the next term of the sequence, we're going to take the previous term. And what are we doing each time? Well, we're going down. Well, you can tell we're not subtracting each time. When we go down, it'll either be dividing or subtraction. But it's not subtraction, so it leaves us with, it must be dividing. And if you notice, it's dividing by 3 each time. Sometimes it's easy to tell that with the smallest ones, because 12 divided by 3 gives you 4. So you can write it like this if you want. And this one, it doesn't matter. We can have decimals. It's not a story problem. It looks like it might keep going for a while. So you can just write for integers where n is greater than or equal to 2. Okay, so hopefully you have a better understanding now of what a recursive formula is all about. And good luck on your assignment.